The question of what lies at the edge of the observable universe has intrigued scientists and enthusiasts for centuries, fueling speculation and theories. Recently, the James Webb Space Telescope, JWST, has offered a significant breakthrough in uncovering this cosmic mystery. With its powerful lenses, the JWST has been able to peer further into space than ever before, offering new insights into the universe's boundaries. To understand this, it's important to first grasp the concept of the observable universe. This term refers to everything we can detect, measure, and study from Earth or through space-based instruments like telescopes and exploratory probes. It includes stars, galaxies, and other celestial objects within our reach. However, it's vital to distinguish the observable universe from the entire universe. The observable universe is just a small portion of the total universe, which remains largely unknown. The observable universe is estimated to have a diameter of about 93 billion light-years. A light-year is the distance light travels in 1 year, about 5.88 trillion miles, or 9.46 trillion kilometers. The observable universe spans an immense area of roughly 93 billion light-years across. This vast expanse traces back to the birth of the universe itself around 13.8 billion years ago, when the Big Bang triggered a rapid expansion. Since that moment, the universe has continued to grow at an ever-increasing rate, driven by mysterious forces like dark energy. As the universe expanded, particles of matter began to coalesce under gravity, forming structures such as stars, galaxies, and planets like Earth. Over countless years, these astronomical bodies grew larger and more complex, giving rise to the rich variety of objects and phenomena we observe today. Despite the universe's vastness, much of it remains empty. To put it in perspective, if we were to shrink our entire solar system to the size of a quarter, the nearest star would still be the distance of 2 soccer fields away. Just within our Milky Way galaxy, one of billions in the observable universe. But why can't we see the entire universe? There are 2 key reasons for this. First, light takes time to travel through space, meaning that when we observe distant objects, we are seeing them as they were in the past. The further away an object is, the longer it takes for its light to reach us, essentially allowing us to look back in time and study the universe's history. The second reason is the expansion of the universe. Imagine dots on the surface of an inflating balloon. As the balloon inflates, the dots move further apart. This principle applies to the universe as well. Galaxies are receding from each other as space itself stretches. This expansion causes the light from distant galaxies to stretch into longer wavelengths, a phenomenon known as redshift. Eventually, some objects will move beyond our observational reach as they recede too far for their light to ever reach us. Given these factors, it's no surprise that we haven't yet seen the entire universe. The concept of the universe's edge remains one of the most profound and mysterious questions in cosmology. Various theories have been proposed about what lies beyond the observable universe, and 3 stand out. The first theory suggests that the universe is infinite, expanding indefinitely in all directions. This idea is supported by the cosmological principle, which states that the universe looks roughly the same in every direction. If true, this would imply that the universe has no edge and extends forever. The second theory proposes that the universe is finite but without a clear boundary. It's likened to the surface of a giant sphere. If you travel far enough in one direction, you would eventually loop back to your starting point. This suggests a closed, finite universe without an observable edge. The third theory is the multiverse hypothesis, which suggests that our universe is just one of many. Imagine a collection of parallel universes, each with its own set of physical laws and properties. These universes could be entirely different from one another, or they could be somehow connected. Now, let's shift our focus to a tool that has the potential to help reveal some of these cosmic secrets. The James Webb Space Telescope, JWST. This remarkable telescope allows us to peer back in time and discover objects from the early universe. With its advanced capabilities, the JWST has enabled astronomers to look deeper into the universe's past than ever before, and it has uncovered some astonishing findings. In a groundbreaking study published in the journal Nature, the JWST discovered 6 massive galaxies that existed between 500 million and 700 million years after the Big Bang. Scientists had expected to find only small, newly formed galaxies from this time, but the JWST surprised them with much larger galaxies than anticipated. These universe breakers have challenged previous models of galaxy formation. In fact, one of these galaxies is believed to have a mass up to 100 times that of our Sun, while the Milky Way contains the mass equivalent to about 60 billion suns. The JWST's infrared technology allows it to detect faint light from distant stars and galaxies, including those that formed billions of years ago. This means the telescope is providing a window into the universe as it appeared around 13.5 billion years ago, just shortly after its formation. What makes this discovery even more fascinating is that the universe is estimated to be around 13.7 billion years old, making these findings incredibly close to the universe's beginning. This revelation has upended much of what scientists thought they knew about early galaxies. Previously, it was believed that galaxies began as small clouds of gas and dust that gradually grew over time. However, the appearance of these massive galaxies has forced scientists to rethink their understanding of cosmic evolution. When the JWST's high-resolution images and data were released in July 2022, astronomers were stunned by the sight of these enormous galaxies, which appeared far brighter than anything they had anticipated. This unexpected discovery has led scientists to question their interpretations of the data, as these galaxies seem to defy previous expectations and challenge our current models of the early universe. In summary, the JWST has opened new doors to understanding the universe's past and its boundaries, revealing surprises that could reshape our understanding of cosmic history. It holds the potential to shed light on the mysteries of the universe's edge, and perhaps even reveal answers to the age-old question of what lies beyond the observable universe. Using advanced spectroscopic techniques to study light across various frequencies, researchers can uncover vital information about distant worlds, including their composition, size, and distance from Earth. What's particularly exciting is that some of the most significant discoveries made by the James Webb Space Telescope, JWST, were not initially expected. These findings emerged much faster than anticipated, and even surpassed scientific predictions. In fact, there's a chance that some of the objects identified using JWST data might turn out to be something completely unexpected. While many of these objects are likely galaxies, it's possible that some could be hidden supermassive black holes. A particularly intriguing discovery is the newfound understanding of the mass of stars in the universe. It's now believed that the total mass of stars in the universe is significantly greater than previously thought, about 3 times more than we had estimated. Even if we only consider half of the sample, this revelation remains groundbreaking. In another astonishing breakthrough, a global team of astronomers using the JWST has identified the oldest and most distant galaxies ever confirmed. These galaxies date back to a time when the universe was just a fraction of its current age, less than 400 million years after the Big Bang. The light from these galaxies has traveled to us for over 13.4 billion years, as detected by the telescope. Similar to the early findings made by the Hubble Space Telescope, JWST's first images revealed several potential galaxies. Through careful spectroscopic observations, astronomers have now confirmed 4 of these objects, allowing them to study not only the properties of these galaxies but also to accurately measure their distances. To calculate a galaxy's distance, astronomers use a method called redshift, which measures the stretching of light caused by the expansion of the universe. As objects move away from us, their light shifts toward longer, redder wavelengths. While redshift values can be estimated from images taken through different filters, spectroscopy provides the most accurate measurements by breaking down the light into its individual frequencies. The new discoveries focus on 4 galaxies with redshifts greater than 10. These galaxies are incredibly distant. For instance, the Hubble Space Telescope had previously observed 2 of these galaxies with redshifts of 10.38 and 11.58, but JWST's images revealed even more distant galaxies with redshifts of 13.10 and 12.63. A redshift of 13.10 corresponds to a time roughly 13.5 billion years ago, offering a glimpse into the early stages of cosmic history. JWST's High Redshift Extragalactic Survey, JADES, is an ambitious program that has dedicated a significant portion of the telescope's time to exploring the early universe. Launched in 2015, the JADES initiative formed a global collaboration of over 80 astronomers and scientists from 10 countries. It focused on a small region of the sky, including the Hubble Ultra Deep Field, which has been studied for over 2 decades using various large telescopes. By observing this area across 9 different infrared wavelength bands, the JADES team discovered nearly 100,000 distant galaxies, each billions of light-years away. Using the NIR-SPEC spectrograph, researchers collected light from 250 faint galaxies during a 3-day observation period. This allowed them to analyze the gas and stars within these galaxies, providing precise redshift measurements. With these measurements, astronomers can estimate the intrinsic brightness of these galaxies and the number of stars they contain. This offers valuable insight into the development of galaxies over time, even without direct knowledge of their early stages of formation. Studying galaxies, especially in their infancy, can be challenging. Just as early life experiences shape an individual's future, the early stages of star formation significantly influence the future of galaxies. We're currently living through a remarkable period in astronomical history, with the JWST unveiling answers to long-standing questions about galaxy formation. NASA's space-based observatories are reshaping our understanding of the cosmos, uncovering a treasure trove of new discoveries. Launched in December 2021, the James Webb Space Telescope, JWST, is expected to operate for at least 2 decades. It has already begun surpassing the expectations set by its predecessor, the Hubble Space Telescope. JWST's stunning images and detailed data are captivating both scientists and the public, fueling a surge of scientific excitement. People worldwide are eagerly analyzing its raw data, sharing its breathtaking images, and gaining new insights into the universe. Since going online in June 2022, JWST's powerful instruments have revealed thousands of previously unknown galaxies, older and farther away than we ever thought possible. The telescope's capabilities also enable researchers to capture light from celestial objects like exoplanets and young stars, allowing them to determine their composition and track their movement through space. This vast influx of data is already providing fascinating insights into the atmospheric composition of planets hundreds of light-years away, hinting at their potential habitability. Furthermore, by studying faint traces of light from the early universe, JWST may have identified the oldest black hole ever observed. This massive black hole, with a mass 9 million times that of the Sun, resides at the center of a young galaxy that formed only 570 million years after the birth of the universe. Thanks to JWST's powerful instruments, which can peer back to the earliest moments of the universe, astronomers are gaining unprecedented insights into the formation and evolution of galaxies, stars, and planetary systems. Each new discovery brings us closer to understanding the universe's origins, and the James Webb Space Telescope continues to be a testament to human ingenuity and our boundless curiosity about the cosmos. With even more groundbreaking discoveries on the horizon, the telescope promises to reveal many more wonders in the years to come.